Jó, akkor ezzel hivatalosan is jó reggelt, sziasztok! Nagyon szépen köszönjük, hogy részt vesztek a nyári tábor legújabb eseményén, és ezzel az előadónk fölállt és elment. Reméljük vissza fog térni. Mint ahogy az elmúlt hetekben elmondtuk, gyakorlatilag minden héten reggel jelentkezünk egy rövid előadással, mindig más témában, alapvetően hálózati, digitális munkahely, illetve adatközponti témákkal jelentkezünk. A mai napon a VMware-nek a load balancing megoldásáról lesz szó, ez az AVI Networks. Főleg a modern applikációk miatt gyakorlatilag egyre nagyobb a hangsúly a megfelelő load balancer megoldáson, és erről fog a horvát kollégám beszélni. Át is adom neki a szót, és gyakorlatilag az előadást rögzítjük. Ha közben bárkinek kérdése van, akkor akár kézfelnyújtással, akár a chatbe, akár a Q&A-be lehet jelezni. Én fogom neki jelezni az előadás közben, és akkor meg fogja tudni válaszolni az esetleges kérdéseket. Köszönöm. Máté, I'm stopping share. I did a little introduction, so you can share your content now, and please go ahead.
Okay, thank you, Yasin. Hello, everybody. Just please give me a second to share my screen. Okay, now that. Screen sharing.
It's perfect.
Okay, can you see the screen?
Yes. Yes, perfect. Mate, meanwhile, you muted yourself, so.
Okay. Can you hear me now?
Yes. Absolutely, yes. Go ahead.
Okay, so I hope that we will finally end with these remote meetings and start to see each other face to face, because this mute, share screen, everything drives me crazy. I don't know what about you. So hello everybody once again, good morning, and thank you for this opportunity to introduce myself. So I'm Mate Grbovac, lead solution engineer for a virtual cloud network. I'm from Zagreb, so Croatia, and I'm responsible for this, let's say, pre-sales part of virtual cloud network portfolio for Hungary, Croatia, and Slovenia. I'm with VMware for the last half a year, so since the beginning of this year, and I have about 15 years of experience in networking. I also have a few industry certificates like Cisco CCIE data center, VMware certified implementation expert for the networking and security, as well as F5 specialist. Today's topic is related to the application delivery and especially application security, because I think that applications are, let's say, big important of our lives, regardless are we talking about private life, business life, etc. Because to the application today we are doing a lot of things, and we will do it more in the future. We are paying our bills, we are learning, we are playing, we are educating our kids, we are, I don't know, driving our cars using different applications. And as that impact of applications to our life is getting bigger and bigger. Of course, that this puts a high demand to the IT infrastructure, to the security, and basically there are a lot of changes that are happening, and on the other side, management requires to do more in shorter time with less resources, and with that demands, we are going to from on-premise solution to the cloud, to the containers, to the microservices, etc. We in VMware, of course, we are aware of that, and basically our mission was and still is basically to make all this infrastructure, let's say, more adaptable and more scalable, and let's say better fitted for this application and the market changes. And through the last, let's say, 10 to 15 years, we virtualize basically all the crucial infrastructure. So we virtualize compute, we virtualize storage, and we virtualize network. But there is still one very, very important component which is still not virtualized, or at least, let's say, adopted to this software-defined model. And this component is a load balancer. But load balancer itself is basically very, very important component in whole this story, because with load balancer is enabling us, for example, to scale out. It provides us high availability, migration to the cloud, migration to the containers, and everything. So it is very, very important, actually, component of the infrastructure. And more of that, its role will getting bigger in the future, because on the load balancer, we are usually using web application firewalls. So it has a big security role. And basically, it will enable us for the transition from a classic application to the cloud native application to the modern applications. And it will enable us to use all these, let's say, microservices, container, and Kubernetes story, because load balancer is very, very important part of all this story. Now, what we have now? So now load balancers are still, let's say, appliance-based devices and solutions. So we have appliance. It can be physical, usually it is still physical, or it can be virtual. And with this approach, we always are facing the same problem, and these are capacity predictions. So when we need to buy new load balancer or new application delivery controller, we are buying it for the next 3 to 5 or maybe 7 years, and we need to predict how much traffic will we have in this next 3 to 5 or to 7 years. We of course cannot, we don't know that, and we usually buy big box or big license, and we are not use all the resources we got. But of course, we need high availability. Then we will buy another box, which will basically will not be used because it's here for standby. We need to have active and standby. So we have 2 boxes, and both of them are oversized, overcapacitized. In our environment, we have different security requirements. We have a different environments, so production, DMZ, maybe test development, etc. And security usually says, okay, you cannot use device from one security zone in different security zones. And what are we doing then? Okay, we need another pair of load balancers per different environments, maybe per different sites. And all of this is now just multiplied. And we end up at the end with a lot of devices, or which of them half are not used at all, and other half is used maybe not 80 or 100%, but a lot less of that. And when there is some kind of, let's say, capacity problem in some environment, for example, we don't have enough resources, we still cannot reuse other resources from other environments because simply these resources are allocated somewhere else, on some other location, in some other environment. And basically, we again stuck into the problem. And now when you see this picture, from my experience, like I said, I was working before with as well system integrator. We were working for one bank, and that bank had 15, so 15 load balancers in their environment. So on primary location, they had 5 pairs, so 10 devices high available, and on disaster recovery location they had again 5 devices, 5 environments, but they didn't have high availability. So can you imagine what effort is needed to manage 15 different devices? It's not easy because you need to pay support for that, you need to patch everything, you need to configure everything, and at the end you need to troubleshoot everything when something is not working. So again, with all that approach, this customer, and this is related to the all customers which are using, let's say, this kind of traditional approach, they had a problem what to do with the cloud tomorrow and or today, or what to do with microservices, with Kubernetes, with containers, etc. So what we did in VMware is that we basically divide or put this software-defined model to the load balancer. So load balancer, like any other component, we can divide it into 2 pieces. One is the data plane, so part of the solution which is handling the traffic, doing load balancing, doing web application, firewall inspection, etc. And the other part is the control plane. And what we did basically, or what AVI Networks did, it basically that we distribute data plane across whole our infrastructure, across whole our environment. So one location, second location, on-premise, cloud, virtual, containerized, etc. environment. So we distribute this data plane and put all the control into central controller, which is handling basically control plane. And on that controller, we are doing management, we are doing troubleshooting, we are doing upgrading, and we have all analytics, visibility, and troubleshooting. And basically, idea behind all of that is that in the legacy virtual load balancer like F5, like Citrix or any other vendor, they are very rich with features, but they are not adopted to this software-defined model. They are not adopted to use in the cloud-native apps, in the cloud, in the container, Kubernetes, in virtualized environment. And on the other side, we have cloud providers, load balancers like AWS, Azure, Google Cloud Platform, etc., which are very adapted to this cloud and the software-defined model, but they are, let's say, they don't have such feature richness. And basically, what we did with AVI is that we try to combine both from all worlds. So from one side, we are very feature rich. We have a lot of feature. I will mention them later. And on the other side, we are very, very adapted, and basically we did solution with SDN concept in our mind. So our solution can work and can cover bare metal solution, virtualized solution, different cloud solutions, different Kubernetes and microservices environment, etc. So, like I said, whole idea is deploy controller, so it's a virtual machine or a cluster of 3 virtual machines. Controller can work in cloud, can work on-prem, can work in different public or hybrid or private clouds, and we have data planes. Data plane, these are basically service engines, so tiny virtual machines or Kubernetes pods, which are running in our environment and handling traffic. And from one single controller, we can control different service engines which are running across all our physical location, across our maybe public cloud tenants in the Azure, AWS, etc. Or we can manage load balancing in our Kubernetes environment. So we are simultaneously controlling all our, let's say, load balancing service across whole our infrastructure, regardless the form factor of service engine itself or a service which is load balanced, etc. So it's not important what are we load balancing and where the services are. We can control and manage everything from one single controller. So through this controller, we have central orchestration. We have, of course, elasticity. For example, if we deployed one service engine in our environment, which will load balance our web applications, and after the load increases, for example, over the 80% on this service engine, our controller will automatically, let's say, scale out and create additional service engine and divide the load across these two service engines. We have, of course, resilience. For example, if the one service engine fails, the controller will automatically shut down and bring up another service engine which will take over the traffic. And of course, we have full automation, and the solution works basically itself. It can be integrated with different automation solutions, from vRealize automation to the third-party automations, etc. And it is integrated with different other solutions, like it can be integrated with VMware NSX, with VMware Virtual Center, with OpenStack, etc. It is, I need to, let's say, emphasize that AVI is, can be fully standalone solution. So you don't need VMware vSphere or VMware NSX to run AVI load balancing or AVI application delivery solution. So you can use AVI as a standalone product, and it can work on Microsoft Hyper-V, on OpenStack, it can work, of course, on VMware, it can work on bare metal, but the best value we can provide when you integrate solution, especially if when you have VMware NSX, VMware vSphere, or a full VMware stack. So regarding the features and the capabilities we are supporting, we have local traffic management. So this is a local application delivery, or basically pure load balancing. We have a global traffic manager, or a global load balancing, so DNS based. This is something like GTM on the F5. We have as well application security and web application firewall. And of course, container ingress services for Kubernetes, as well as for VMware Tanzu, for different other Kubernetes solutions like OpenShift Rancher, etc. And I would like to mention here that basically security is the direction in which AVI will be developed in the future. So most of the feature which will be available in the future will be related to the security, so to the web application security, to the microservices security, and to the application delivery in this container and microservice environment. And like I said, all of this is working on bare metal, in virtual environment, in cloud environment, as well as in a container environment. And all the features are again controlled from one central point, which is orchestrator. So pure software-defined model for all our applications, regardless of the form factor and location. Regarding the use cases, so from the on-prem solutions, we are supporting integration with NSX, with VMware vSphere. We can work on bare metal, we can work with OpenStack, we can work as a fully standalone solution. We are supporting all relevant clouds, I would say, so AWS, Azure, Google Cloud Platform, Oracle Cloud. We are working with different Kubernetes and containers platforms like OpenShift, native Kubernetes, VMware and Tanzu, Kubernetes in different cloud environments, etc. And we are also supporting end user computing, so VDI, Workspace PAN, Horizon Cloud, etc. Again, all the services in all form factors, everything managed through the one central control point. So from the customer's perspective, customers with Avi will get agility, will get operational simplicity, and will get cost savings. And all of that I will explain in the next few slides. Avi is coming in the with the few different editions. I believe that you are aware that with NSX Advanced and NSX Enterprise Plus, you will get a native NSX load balancer. In the future, or with next release of the software, of the NSX software, this native NSX load balancer will be replaced with Avi networks. So what does this mean? This means that with the NSX Advanced and the NSX Enterprise Plus, which brings you NSX load balancer, these load balancer features are now available, and you have right to use Avi networks, but with the basic features. And these basic features are basically pure local traffic management and container egress services. And like I said, you will get this Avi basic with enterprise, with NSX Advanced and Enterprise Plus. Avi itself has just only one license, and this license brings you Avi Enterprise, and basically this license unlocks all the features. So local traffic management, global traffic management, web application firewall, and container ingress services. And this Avi Enterprise license is, it can be fully standalone. So NSX is not required if you want to use Avi Enterprise. So it's basically full standalone feature. Avi Pulse, it's basically Avi cloud service, which enables you to automatically download the security threat updates, so security signatures, etc., to the controller. It will it can handle license management, different operations management, etc. So you can basically from the download software directly to the controller. So if you have controller on-prem, you can download new software version to the controller, and after that from the controller distribute this new software version to the service engines. And these service engines can run on your premise, in the cloud, in the containerized environment, etc. So everything again is managed through the one single control point of management. So basic idea behind everything is to have load balancing or application delivery fabric across all the environment. So again, our environment is bare metal, it's virtualized, it's maybe somewhere in cloud, because from a cloud perspective, cloud is, from our perspective, cloud is also infrastructure, and there's of course containers. So we have one controller, we are deploying service engines across all the environment, across all the locations, and we are managing everything through the single GUI. And on that controller, we have as well API, so application interfaces through the which we can integrate with different solutions. And for example, if we have our services running on the multiple service engines, and for example, this third service engine here, which is handling some traffic, is going down for some reason, controller will know that, it will distribute all traffic to the other service engines in these groups. It will bring up new service engine and get back traffic to this, let's say, first one service engine. All the solution is multi-tenant, so you can use different tenants, and tenants can be different user, different environment, maybe production, test development, etc. Or it can be different users, different companies inside the one, let's say, big company, etc. This example shows us upgrading of the system. So we have different service engines, some of them running in the cloud, some of them are running on-prem in different tenants. And what we can do to the controller, we can, for example, select specific service engines and put new software versions. And basically on that way, we are not affecting all the users and all the traffic. We are affecting just traffic and services which are related to this particular service engine. Why this is important? Because when you have big boxes for load balancing like F5, Iprion, etc., all your services and basically all your production is running on that one pair of the boxes. And for example, when you are doing upgrade, you are affecting all the services which are running on this big box. In this approach, everything is distributed, and so application delivery service is distributed. Your business services are distributed across these different service engines, and basically you can choose what do you want to upgrade and when you want to upgrade which part of your infrastructure. Okay, now about elasticity and auto-scaling. So with the AVI, we are supporting horizontal and the vertical scaling. So vertical scaling is basically when you have service engine with one core, and when you want to provide more resources, you put additional cores into this service engine. So for example, you create service engine with one core, and you add then a second core, third core, up to 32 cores. So you can have service engine with 2 cores. In the horizontal scale out, you can have a service engine with one core or maybe with more cores. And basically when you want to scale out, you are not adding cores to the service engine. You are basically adding additional service engines in parallel to this existing first one. Core is basically virtual CPU. For example, if you have a service engine with 2 cores, basically with 2 virtual CPUs, you are using 2 cores. And what are we licensing in the AVI are basically these service cores. So you are basically buying pools of these service core licenses. For example, you can buy a license for 10 service cores, and basically you can use these 10 service cores maybe on one service engine. So you have one service engine with 10 cores, or basically, or you can have 5 service engines each with 2 cores. So at the end, sum is 10. And basically, you can use these service cores across all your environment. So basically, you buy bundle of service cores, and you can use these licenses on one location, on second location, in the cloud, etc. Basically, you have this truly network-wide deployment and licensing model. And for example, if you shut down some service engine, so service core license from that engine will get back to the pool, and you can use somewhere else. And basically, when you want to scale out, all you need is to buy additional service cores, and you can deploy additional service engines. And this is very different with all other solutions in the market, because, for example, with F5, F5 is licensing features, and it's licensing throughput on the virtual machines. For example, if you buy a local traffic manager with 200 megabits and you put it in your one data center, these resources are in your data center. You cannot use it, for example, in the cloud at the same time or somewhere else, because the license is related to this virtual machine. With Avi, you basically create, put pool of service cores to the controller, and you can use licenses from this pool across all your environment. And if we use this example with 10 service cores from the beginning, 5 of them you can use in primary location, 2 of them you can use on the, let's say, DR location, 2 of them you can use in Google Cloud, and 1 of them you can use in Azure, etc. So truly network-wide model. And what is more important, with this Avi license, you get all the features. So when you buy Avi Service Core, you got local traffic manager, global traffic manager, web application firewall, and container ingress service. So we are not licensing features, we are just licensing service cores, and you can use it wherever you want, whenever you want, with all the features. Automation, so we are supporting all, let's say, automation applications and services on-prem, from the cloud, etc., operational and infrastructure. And again, we have a very well documented API, and basically, if you are skilled, you can create your own let's say automation solutions, or if you have something which is existing inside your environment, it is very easy, let's say, to automate things, etc. And analytics, this is maybe my favorite part of the Avi. We are near the end. I know that we are already exceeded our time. So basically, controller is collecting all the analytics from all the service engines, which is management from which are managed from that controller, and basically it collects everything, all the requests, all the headers, everything, and put it in into its database. And this is a big database. This is big data, and it has big data analytics. And on the controller, you get visibility into different, let's say, statistics. And for example, it can show you for a particular request, for particular user, what was, for example, client round trip time, what was server round trip time, what was application response, what was total response time, etc. And basically how this looks in the GUI, it looks like this. For example, you can go historically because everything is logged. You can select client by different parameters, so by IP address, by location, by operating system, by a service to which client access, etc. You can dig down, and for that particular request in the GUI, you will get all info about client, so IP address, location, operating system, device, browser, etc. About virtual service on the Avi networks, and about application. So the GUI will show you what was the response times, what was the HTTP codes, what was application response codes, etc. And it will give you all the information on the application level. So HTTP request, what was URI, what was user agent, etc. So try to get all these informations in, let's say, this view, so all together in one place from any other existing application delivery solution. I think it's not easy. You need third-party tools, and you have a lot of you need to have a lot of time. So basically, in the F5, I believe that you need to enable a TCP dump, or maybe use Fiddler to get all these informations. In the Avi networks, you get everything in the GUI, and like I said, historically. And when I said historically, you can choose what do you want to log. So basically, you can log all the requests that is coming to the AVI networks. But of course, in that case, the resources are not infinite, and you will not be able to keep these logs, for example, for 1 year. You will be able to, let's say, keep them maybe for a month or 2 months. But it's much easier to troubleshoot, because when you come next day to the job and someone said you, look, we had some problems with the application tonight, you can go to the controller, select time frame, select client, or maybe any other parameter. You will get this table, and when you dig down, you will get information like this about particular request, and you will be able to tell the service owner where was the problem, when it happened, for which clients, etc. And with that, you will get also some additional statistical informations about, for example, from security perspective, which certificates our client is using, what protocols, what was there any DDoS attack, what was the web application firewall statistic, etc. So it will provide you a lot of detailed informations, which you, from, if you have some kind of legacy solution, you need third-party tools, and you need to have a lot of manual work to get these informations. With AVI networks, you will get this on the one place, out of the box, and for all your infrastructure. So for the service engines that are running on bare metal, on virtual machines, in the cloud, in the containers, etc. So everything is managed through the one place, and all visibility, troubleshooting, and configuration is again done on one place, which is AVI controller. For example, here is also some other views which you can get. You can as well, of course, have all the insights into the traffic. So basically, cumulative, what is average client response time, server response time. Basically, you can get very good pictures about how your whole infrastructure is working, not just on the infrastructure level, but as well on application level. And basically, you also can see from you have this client intelligence. You can see from where are your client accessing, which percentage, what are top URLs they are accessing from which browser. So you got all the informations which can be pulled out from, let's say, HTTP header and from the traffic which is passing through the AVI controller. Basically, this is everything from my side. I know that we are end of the time, so I will now pass through the questions and try to answer the questions.
I have one question. Let me stop the recording.